two types. First one is Kirchoff's current law. Kirchoff's current law. Kirchoff's current law. It is shortly known as KCL. It is also known as junction rule. Junction rule or node rule. It is sometimes also known as node rule or junction. Junction, as we read, junction is a point where two or more than two conductors join together or meet together. Kirchoff's current law. The statement of Kirchoff's current law is the algebraic sum of all the current at the junction is zero. The algebraic sum of all the current at the junction is zero. And algebraic sum of all the currents at the junction is zero. That is सिग्मा. समेशन के लिए हम लोग यूज करते हैं सिग्मा का. सिग्मा आई इज जीरो. और ये कहाँ जीरो है? एट द जंक्शन. It is clear. An algebraic sum of all the currents at the junction is zero. That is summation of I. Sum of current, total current is equal to zero at the junction. अब यहाँ हम लोग को ये समझना है कि sum of all the currents. How many types of current at the junction? There are two types of current at the junction. First is incoming current and second is outgoing current. This is the junction point. Incoming current, that means the current coming towards the junction. The current coming towards the junction, and the current going outward the junction is known as outgoing current. This is outgoing current and this is incoming current. Two types of current we have at the junction, and the sum of incoming currents and outgoing currents is equal to zero. That is, incoming current is equal to outgoing current. Now we have discussed the incoming current and outgoing current. This one is I1, suppose, and this one is I2. This is current coming towards the junction, and this one is current coming outward the junction. Third one is the current coming towards the junction and is indicated by I3. And the fourth one is the current going outward from the junction is I4. I1, I2, I3 and I4. Now this is the junction. According to Kirchoff's current law, I1 plus I4 plus I2 plus I3 is equal to 0. I1 plus I4 plus I2 and plus I3 is equal to 0. All the currents, sum of all the currents at the junction is 0. Now, to discuss more Kirchoff's current law, we have to study the sign convention. Sign convention. Sign convention. Here, there are two types of current, incoming current and outgoing currents. Remember, incoming current, that is the current coming towards the junction is taken as positive, and outgoing current, that is the current going outward from the junction, is taken as negative. This is the sign convention for Kirchoff's current law. Incoming current which is taken as positive, outgoing current which is taken as negative. Now apply Kirchoff's law for this figure. Here, according to Kirchoff's law, current I1, and I1 is the incoming current, so this is taken as positive. Current I2 is outgoing current, and according to Kirchoff's law, this is taken as negative. Plus, third one is current I3, and this is the incoming current, and that's why it is taken as I3 is equal to I2 plus I4. And now we see here that I1 is the incoming current, I3 is also an incoming current, whereas I2 and I4 is the outgoing current, and the result is incoming current is equal to outgoing current. According to Kirchoff's law, incoming current is equal to outgoing current. This is a point junction, and this is a point. There is no accumulation of charge. Remember that there is no accumulation of charge. The total amount of charge entering at the junction is equal to the total number of charge leaving the junction at the same time. याद रखना है कि जितना चार्ज, जितना करंट जंक्शन के पास आता है, उतना ही करंट उस जंक्शन से उसी समय वापस भी चला जाता है. That's why incoming current is equal to outgoing current, and which explain the law of conservation of charge. Law of conservation of charge. Kirchoff's first law is based upon the law of conservation of charge. There is no accumulation of charge at the point of junction. The total number of charge entering at the junction is equal to the total number of charge leaving the junction at the same time. Clear? Now, we solve a numerical problem on the Kirchoff's current law. See, a numerical question based upon Kirchoff's current law. How can we find the current in different arms? See here. In this arm there is a current of 15 ampere. This is example of Kirchoff's current law. 15 ampere. And here there is a current of 7 ampere. And here there is a current of 3 ampere. Here there is a current of 3 ampere, and in this arms there is a current of 5 ampere. Suppose, find the current in these arms. Find the current in these arms. इस आर्म्स में हमको करंट फाइंड करना है. अब हमको ये देखना है कि 15 एम्पियर का करंट यहाँ से चला. दिस इज अ पॉइंट ऑफ जंक्शन. 15 एम्पियर के करंट से 7 एम्पियर का करंट इधर चला गया. दिस इज द करंट लीविंग द जंक्शन, एंड दिस इज द करंट इनकमिंग टुवर्ड्स द जंक्शन. तो 7 एम्पियर चला गया, तो इस आर्म में कितना बच गया? 8 एम्पियर का करंट बच गया. अब यहां से 7 एम्पियर का करंट आया. दिस इज ऑल्सो जंक्शन, एंड इधर से भी ये जो करंट आपको दिख रहा है, दिस इज इनकमिंग करंट. तो हियर टोटल करंट इज 7 एम्पियर एंड 3 एम्पियर. नाउ in this arm there is a net flow of 10 ampere. Again 8 ampere current is entering at the junction, in which 5 ampere is and 3 ampere is in this arms. 10 ampere is entering at this point and 3 ampere of current is also entering at this point, and total current in this arm is 13 ampere. Total current in this arm is 13 ampere, but the direction is in upward, so we take this current as negative 13 ampere. Why? Because this is the current leaving the junction. Thank you. Next day we will study about the Kirchoff's voltage law. Thank you very much.